We have a Bone Busters MPU board, and I have just finished cleanly removing the daughter card and replacing it with a machine pin socket and a new daughter card of my own design. It's got McZonk's Free Play ROM in there now, and I did put labels on these ROMs. Bone Busters does not get a slam switch modification. Bone Busters wants the slam switch open, and I also have installed a CR2032 battery holder. This had some corrosion on it at one time. Somebody cleaned it up. It works. It's good enough. I don't see any corrosion that's really gonna carry on, so there's really no reason to put any more time into it. I tested the 6532 on my bench. It was good. Did have a dead 7404 there, which I replaced with the 7404 that I pulled off of the OEM daughter card. Let's boot it up. And that is characteristic of a clean boot. You'll note with McZonk's ROM, you get the FP for Free Play. The lamp matrix, or not lamp matrix, all the lamp drives being driven by the driver board that also came along with it appear to be working, but we'll put it through its tests. So I'm going to use my simulated switch matrix testing device and enter test, skip to lamp test. And all the lamps are working perfectly fine. Solenoid test. The green LEDs that are coming on are pre-drive transistors for underplay field transistors. And Bone Buster used quite a few of those. Test really got complicated after Gottlieb started to make their games more complex. You can see we've got a switch matrix failure here. It's always reporting all the switches in, or that end in 2. Now, is that row 2 or column 2? I don't remember. Let me, let's see, I'll close another switch. 31, okay. So the second digit is the row number. This will be switch 30. Nice that it does them in numerically ascending order, so it looks like we have a row 2 problem. And that's not too surprising, but let me get some schematics up and we'll see if we can figure this out. All right, so here's a representative schematic. And row 2 comes into Z13, and the signal is NANDed. This is a not AND gate with the signal that comes from the dip switches. But the signal from the dip switches is supposed to be pulled up to 5 volts via R36. And when I probe pin 1, I get nothing. So now let's go find where R36 is. And here it is right here. Is the third one from the right in the rather famous bank of resistors. I'm probing the top side and it's high. I probe the bottom side and there's no signal. And I just went through this on a different brand CPU the other day. See how there's no signal on pin 1? The odds are, well, there's 2 possibilities. One is this resistor is open, or this chip is shorted internally to ground. Of those 2 possibilities, the odds are that that 7400 chip is shorted. So I'm going to take that out and be right back. All right, I have replaced the 7400, and let's test the one I took out. And it says 8ERR. That means this chip tester cannot identify this chip, which probably means, well, in this case it does mean, because I know that this chip tester can identify a 7400. It means that 7400 is dead, and I've replaced it with a Tesla 7400 that I've had in my parts bin for ages. Very nice part. The company Tesla made parts for a while. Let's boot up. And it would help if I applied power. Let's get the power connector connected. Now let's boot up. There we go, much better. We've got the lamps dancing, as Leon used to say. So let's get into test now. Skip ahead by pressing the credit button to lamp test. Let's skip those two because we've already done those. Now here's switch test, and that's a good sign. All switches open. So I'm going to go across the diagonal of the switch matrix, and we'll see 0, 0, 1, 1, 2, 2. Well, we missed the 1, 1 there, so there's some additional problem here, unless I have a test board problem, but looks like 1, 1's not working. Let's see if 10 works. No. And let's see if, there's 10. So that is column 0, 1, row 0. Here's column 3, row 0. Here's column 3, row 1. So nothing in row 1 is working. So now, why would that be? Because I believe that same chip is responsible for row 1 also. And it is. Oh boy. I don't want to tell you what I'm thinking right now, but I'm going to have to put a logic probe on here, and I'll be right back. Okay, that ended up being a benchism. I reseated the connector A1J6, and now we can go across the diagonal. I'm going to check the pin, the edge connector pin. This board came to me with little nubs of wire still soldered to A1J6, and I removed them all, so it's possible that that pin, and it is pin 11, is going to need a little bit of dressing up, but I'll check that when I pull the board off. Now this board, let me start all over again. Booting up. Lamps are being driven. MPU doing what it does for high score to date. Skip to test mode. Looks good. We go to relay and solenoid test. I was watching each of those. One thing I don't like about this board that I got from Pascal is solenoids 2, 6, 9, 1, and 5. They're not even in numerically ascending order, or separated from the other solenoids up here. And I know why he did it. They come off of different connectors on the board. But if I was designing this board for myself, or if Victor were designing this board, we'd put all of those solenoids in numerically ascending order adjacent to each other. So we'll skip that again and go into switch test. Why don't I go, well, I'll go through the diagonal one more time. Yeah. We're good to go here. The next test is the dip switch settings. 01070343. Correct. And display test. By the way, this is the Lizzie Project display. Very nice. I love it. And we're good to go. All right, I'm calling this one good. Thank you so much for sending it. We are all done with all three of these boards, the driver, the MPU, and I always put these tags on them with a date that shows what I found and what I replaced. I also ask clients that have System 80 boards that the power supply hasn't been rehabbed to send that in along also, because these headers get tarnished, resistance builds up, your voltages can go askew. There's two of them on here, but the bigger problem is the pot that was on here from the factory is just a really crappy pot. So I always use these Thermet pots. They're a sealed pot that I get from, or I used to get from Ed at Great Plains Electronics. Quality stuff. This power supply, yeah, I know it uses an LM338 linear regulator, but this thing will outlast probably any aftermarket regulator or power supply that's being sold today. I've never seen an LM338 fail.